Okay, it is 6 o'clock. So we'll get started. Thank you everyone for joining us for our first late night of the 2022-2023 academic year. This will be our last virtual late night at the museum event, and starting next month, so in November, we will return to our in-person late night events at the Geology Museum. So we really hope that people would be able to join us in person next month and for the first week of the month for October, November, December, and then February through May in the spring semester. So thank you for everyone who's joined us virtually for these events. We still will continue virtual events with our Ask of Geologists series, which we will have announcements of that coming up very shortly. So thank you everyone for joining us for our Planetary Geology late night. We have a fun night lined up. We're going to start off with some trivia. Then we'll do a short craft, and then we have a guest speaker who will be joining us from Texas, I believe, who was a former undergraduate student at Rutgers and is now getting her PhD in Texas in planetary geology. And she's going to talk a little bit about some of the work that she's doing. So fun night for sure. But I'm going to turn it over to Ria, our tour guide extraordinaire, who will lead us in the trivia tonight.
Thank you, Lauren. Okay, so let's get started. And the way that you can join us for trivia is you can scan that QR code, or you can just go to menti.com and you can enter that 8-digit code that's on the screen there, 836-05095. All right, so go ahead and scan that QR code or join from Menti. I'll give you just one more second to do that. Okay, so let's get started with our first question for tonight. Number 1, how hot is the surface of the sun? A, negative 1004 degrees Fahrenheit, B, 465 degrees Fahrenheit, C, 5476 degrees Fahrenheit, or D, 9941 degrees Fahrenheit.
Okay, we have a couple people answering on Menti. If you were unable to log on to Menti to answer, feel free to put your answers in the chat, either on Zoom or on Facebook Live. So right now we have a split, people answering A, C, and D, but the majority right now says answer C.
Okay, let's find out the correct answer. It is actually D. The sun produces heat and called nuclear fusion. And this process produces a huge amount of energy by combining hydrogen. How many planets are there in our solar system? A, 7, B, 8, C, 9, or D, 10?
And bear with me, it took me a second to remember how to clear the answers from the previous. So if you tried to click before, it didn't go. So try again now. That's my bad. It's been a while since I've had to clear them. So right now we have people picking B and C, but overwhelming majority is B.
Okay, so the correct answer would be B, 8. Pluto's status was downgraded to a dwarf planet because it does not meet the 3 criteria of a full-sized planet. Next question. In what year did scientists decide that Pluto should no longer be a planet? A, 1979, B, 2006, C, 2010, or D, 2022?
Okay, just a few people answering so far. We have a dead even tie between B and C right now. Let's give another couple minutes, a couple seconds to see Okay, so we have majority of people picking C right now.
Okay, so the correct answer is actually B, 2006. Pluto is now classified as a dwarf planet because it has not cleared its neighboring region of other objects. Number 4, which planet was the first to be discovered using a telescope? Was it A, Uranus, B, Mars, C, Jupiter, or D, Neptune?
Okay, choices coming in. Right now we have a pretty even split between A, B, and C. Let's see if anybody else wants to vote. A couple more coming in. So we have most people saying B and then a tie for A and C.
Okay, so let's find out the correct answer. Actually, A. Uranus was discovered in 1781 by astronomer William Herschel, who first thought it was a comet or a star, not an entire planet. Question 5. Which planet in our solar system is the smallest? Is it A, Pluto, B, Venus, C, Earth, or D, Mercury?
All right, we had a lot of fast answers coming in for letter D, like immediately after you posted the question. So most people are saying letter D, and we have a couple saying A, but majority is D.
Okay, so let's see. And that is correct. Mercury is the smallest planet, and it is also the closest planet to the sun. Okay, and if you're just joining us or if you joined a little late, we are playing planetary trivia. So if you'd like to join us, you can scan that QR code, or you could also go to menti.com and enter in that 8. And make sure to keep track of your score because we'll talk about at the end we'll see how you all did. So don't forget to keep track. Okay, question number 6, which planet is the coldest? Is it A, Mercury, B, Uranus, C, Neptune, or D, Saturn?
All right, we had a bunch of answers come in for C right away. We have a few for letter B. Oh, and there's one for letter D. So B and D are tied, but C is still the overwhelming majority right now.
Okay, so the correct answer is B, Uranus. The surface temperature on this planet is negative 371 degrees Fahrenheit. Very cold indeed. Question 7. Which planet has the hottest surface temperature? A, Mercury, B, Venus, C, Earth, or D, Mars?
Okay, we've got split between B and D right now. But B is pulling ahead by a large margin right now. Yeah, most people are saying B still.
So it is B. Venus's thick atmosphere causes its greenhouse effect to be much stronger than any other planet, making the surface heat up to 867 degrees Fahrenheit. Question 8. Which planet has the most irregular revolution around the sun? Is it A, Mercury, B, Earth, C, Jupiter, or D, Venus?
All right, we have this will be the first that we have choices for all 4 answers. A and C are pretty much tied for the first choice, and B and D are second. But okay, now we have some more coming in, and C is ahead by a little bit.
Okay, so the correct answer is it's actually A, Mercury. Mercury's orbit is the furthest from the usual ellipse, getting us close as 46 million kilometers and are as 70 million kilometers from the sun during the course of its orbit. Question 9. Which planet is not made entirely of A, Jupiter, B, Uranus, C, Neptune.
Okay. Oh, answers are still coming in. We haven't had that many people respond yet. Oh, we have choices of all four right now, with A, B, and C being very closely tied, and D just slightly ahead right now. But oh, no, nope, I take that back. Now C and D are dead even for first again. They're changing a lot as I speak. So yes, still C and D are the top right now.
Okay. So the correct answer is D. 4 of the planets in our solar system are gas giants, meaning they are made mostly of gases: Jupiter, Saturn, Uranus, and Neptune. Question number 10. Jupiter is a huge planet. How many Earths would fit inside of Jupiter? A, 15 Earths, B, 500 Earths, C, 1,300 Earths, or D, 100,000 Earths?
Right, we had a bunch of answers come in right away for C and D. So C and D are tied, and distant second is B. And it looks like C is pulling ahead by a little bit, but B and D are tied.
Okay, let's find out. The correct answer is C, 1,300 Earths. Jupiter is the largest planet in our solar system and is 2.5 times more massive than all the other planets in the solar system combined. Next question is again, if you're just joining, scan the QR code, or you can go to Menti to join our planetary trivia and keep track of your score. And the next question is, how do scientists explain Jupiter's big red spot? A, a land feature, B, a giant storm, C, a volcanic eruption, or D, the reflection of light off of an ocean?
All right, not many people answering yet. Oh, a whole flood of answers just all came in at the same time. And we have answers for B and C right now, but B is the overwhelming majority.
Not the correct answer. It is B, a giant storm. The big red spot is caused by a giant storm that has persisted for over 340 years and continues to this day. Number 12, how many moons does Saturn have? A, 1, B, 5, C, 39, or D, 82?
Okay. So we have a bunch of answers coming in. It's pretty split, evenly split between B, C, and D right now. Let's see if we can get some more in. Oh, it's more coming in, but it's just as even as it was. Yeah, no one's picking A. C and D are just slightly in the lead, with B close behind. So it's pretty split between B, C, and D.
The correct answer is D, 82. Jupiter previously held the record for the most moons at the time. It was overtaken in 2021 by Saturn, which is now believed to have 82 moons. Question 13. Which of Saturn's moons most resembles Earth? Is it A, Titan, B, Dione or Dione, Callisto, or D, Phoebe? Or Phobo. I forgot how to say that one. Maybe it was Phoebe.
Okay, so we have people selecting all four answers right now. A, B, and C are tied, and then D is ahead by a little bit, but not too much. And we still have some more people saying A. So D is the top choice, with A slightly behind.
Okay, so let's find out. So it's actually A, Titan. Titan is Saturn's only known moon that has its own atmosphere. It also has rain, lakes, and oceans just like Earth. Question 14, what makes up Saturn's rings? Is it A, ice, B, gas, C, space rocks, or D, space rocks and ice?
Okay. So we have people picking A and D right now. Oh, now we have all answers picked. A through C are pretty tied still, with D is slightly ahead. Let's see if anyone else answers. No, oh, there's one more. So yeah, D is still the highest right now.
So let's find out. So D, space rocks and ice is the correct answer. The ice and fragments of rock making up rings come from asteroids, comets, and destroyed planets and are held in orbit around Saturn by its gravity. Question 15. Saturn is not the only planet with rings. Which of these planets does not have rings? A, Jupiter, B, Venus, C, Neptune, or D, Uranus?
Okay. Oh, still waiting for a bunch of answers. Not many people have answered this one yet. Oh, there we go. There goes a bunch. Everyone answered at the same time. We have all choices selected right now. So A and B are dead even for first, with C and D behind. And B just pulled ahead a tiny bit, but not by much.
So let's see what the correct answer is. It is B, Venus. Jupiter, Uranus, and Neptune all have rings, although they are less pronounced than those of Saturn. And once again, if you're just joining us, if you join late, you can scan that QR code to play planetary trivia, or you can join the Menti.com and enter that 8-digit code. And don't forget to keep track of your scores. Question 16, how long in Earth years is a year on Neptune? Is it A, half of an Earth year, B, 1 Earth year, C, 81 Earth years, or D, 165?
Okay, still waiting for people to vote. Now we have every option selected. More coming in. So we have first is D, B and C are tied for second, with a close third. Yep, D is more ahead still.
All right, well, so D is the correct answer, 165 Earth years. Since Neptune's orbital path is longer than Earth's, it takes 165 times longer for Neptune to make one orbit around the sun. It's a very long year. Number 17, how far away is Pluto from the Earth? Is it A, 316 miles, B, 3,160 miles, C, 3.16 million miles, or D, 3.16 billion miles?
Okay, we have people selecting C and D right now, and they are tied. Dead even tie. Oh, but now C is slightly ahead. So C with a close second of D.
Okay, so the correct answer is actually D, 3.16 billion miles. Pluto is so far away that scientists estimate that a mission there would take between 9 and 12 years. Okay, next question is, which of the planets in our solar system do not have moons? A, Mars and Earth, B, Venus and Mercury, C, Uranus and Jupiter, or D, all planets have moons?
I seem to have forgotten everything I learned in the geology of moons and planets course that I took as an undergrad many moons ago. I don't remember the answer to these. So we have people picking B and D, but most of the people are picking letter D right now.
Okay, so let's find out. This is actually B, Venus and Mercury. Most planets have moons, but Venus and Mercury do not. Scientists still haven't determined why Venus has no moons. Question 19. What is the most widely accepted theory on how the moon was formed? A, from fragments produced by a collision with Earth. B, from rock launched into space from the sun's surface. C, from the remains of an old planet that died. Or D, stolen by Earth from another planet.
Okay. So we have people picking A, B, and C right now. B and C are tied for second place right now. And we have A pulling ahead as first. Oh, we have some people picking D, but that's still in third place. So A is first, B and C are second, and D third.
Okay, so the correct answer is A, from fragments produced by a collision with Earth collided with a large rock formation billions of years ago. Debris was produced and sent out into space. The Earth's gravitational pull eventually consolidated the debris into our moon. This one I remember because the name of that rock was Thea, and it rhymes with my name. Okay, the last question we have. What was the name of the first mission that put humans on the moon? Was it A, Luna 1, B, Pioneer 4, or C, Ranger 5, or D, Apollo 11?
Okay, we have answers coming in quickly. Overwhelming majority says letter D, but we have a few answers for letter A, but still D is the runaway winner of this question right now, according to our audience.
Okay, so the correct answer is, I think, okay, there it is. That's D, Apollo 11. Today, a total of 6 missions have landed humans on the moon. Apollo 11 was the first of these missions on July 16th, 1969. And that's the end of our trivia portion of tonight. And so let's see how well you did. So if you got 0 to 10 questions correct, you are a space enthusiast. If you got 11 to 15, you were a galaxy explorer. And if you got 16 to 20 correct, you are an astronaut.
I definitely did not get astronaut on this one because I've forgotten a lot of these facts. So
me too.
Yes.
Okay, well, let us know how you did. You can write it into the chat, or you can just let us know. And we will be starting our craft activity next. So thank you, Lauren, for
thank you, Ria,
doing the trivia. So today we're making toilet paper roll rockets. Sounds exciting. Okay, so we have a QR code here that you can scan. And that will bring you to the Padlet. So when you are finished with your rocket ship, you can please post a picture there so we can see what yours looks like. Supplies you will need are a toilet paper roll, or if you don't have a toilet paper roll, that's okay. You can also have, you can use construction paper. So it's fine if you don't have a toilet paper roll. Don't try and go empty one now. I don't recommend doing that. You will need construction paper or colored paper. You'll need scissors, and if you have glue or tape, that would be great. Okay, so I'll give you another minute to gather your supplies. And then I have my supplies here. And I can show you actually one that I made earlier. Okay, so here's one that I made. And I actually had wrapping paper that was space themed, Chris holiday themed in space. So that's why mine looks like this, but we're gonna make yours too. All right. So the first thing I have here is a toilet paper roll. And what you wanna do first is you wanna actually cover it, okay? If you wanna color it, you can color it too. It's totally up to you. I find that it's a little easier to just cover it. So I have some paper. And if you want to use printed paper like I did, like you have printed paper or wrapping paper that you want to use, you could definitely do that. And I think I'm actually going to use some blue paper for this. I have some right here. Let's see if I have enough. I don't have a perfect size right now, so I'm gonna cut it into pieces. So you want to line it up to the edge. And so that's how long it should be. And then you're going to wrap it around. It's really simple. So since I am missing some here, I'm just going to cut it and glue it there. And if you have excess, if you have extra, you can just cut that off too. Okay, so I have some tape over here that I'm gonna get. You can also use glue, so either one is okay. I'm just gonna tape this on. And for mine, I have a little empty square there, so I'm just gonna cover that up. Okay. Oh, I lost my square. Okay, so it's all covered up. And so now what we can do is we can make the top of our rocket ship. So what you want to do is you want to cut out a big circle. Well, I drew a circle here, so I'm just going to cut that out. I'm going to use orange for mine. So go ahead and draw a really big circle, and you can cut it out. Okay, so here's my circle. And I'm just going to cut, I'm going to find the middle of my circle. And I'm just going to cut one little dash to the center, just so that it's easier for me to make it into a cone shape. So I'm put my finger there, and I can try to poke it out like that. And then you can put tape on that line again. So you can try to like, probably easier to tape it around, or if you do have glue, you can use glue too. I'm just taping my phone to the top here. Okay, so there's the top. And then for the other parts, I have 3 circles here that I was going to cut out. They could be like little windows. So if you want to make windows for your little rocket, you can make windows. Okay. And so if you want to like draw little aliens, or if you want to draw little people and astronauts in your windows, you definitely can. I have cut out a few passengers here. I have a Yeti. I have a festive penguin. And I have, I think it looks like a bear, but actually I think it's a reindeer. That's a reindeer. Okay, so let me just tape my passengers here. Okay, so there's one of my passengers. And then you can just like glue it or tape it on to the side of your rocket. So there's my Yeti. There's my penguin. Okay, so we're almost there. So now what you want to make is actually the wings for your rocket. So you're going to need triangles for this. So you can cut 3 triangles. There's 1, there's 2. I'm going to cut 1 more triangle. And there's my 3rd triangle. Okay, so I'm going to take some of my teeth and take one of my triangles here. And they're just going to go like this. So I'll do one on the back. And if you want it to like stick out, you can like maybe like fold it if you're taping it on, or even if you're gluing it, you can tape a little part flat and then you can just fold it over and then it'll stick out like that. See? I have the orange. I'm gonna put that here. And again, I'm just gonna like fold it over so that it sticks out. Okay. Need one more. And you can decorate any way that you like. You can put other patterns on it. You can make it rainbow colored if you want. Whatever makes you happy. Yeah, I'm just gonna fold it over again so that it sticks out. And there we go. We have a little spaceship. So let's see if any of you have added these to the Padlet. So when you're finished with your rocket, please take a picture and post it to the Padlet site so we can look at that and I'll show you. Okay, so again, like if you want to add your Padlet to the site, you can just scan that QR code. If you want some more instructions or other inspiration, you can click here. Here are the supplies you need a toilet paper roll, construction paper, scissors, and glue or tape. And here's the rocket that I made previously. Yes, let me try to refresh one more time. Let's see if anyone has added any of their rockets yet. I'm sure they're all out of this world. Okay, so maybe you're still making your rockets. That's totally fine. Take your time, be as creative as you'd like. If you want to add pom-poms or like glitter, like do whatever you want. Be as creative as you like to be. But I think we can get started. Lucia, are you ready to take everyone outer space? Okay, so Lucia's here. And so thank you all for doing the craft. And don't forget to take, I think we have, Parker has made a rocket and that looks awesome. Great job, Parker. I love it. I really like the square windows here. Maybe you're gonna put somebody in there. We'll look forward to seeing that. Okay, so yeah, once you're done with your rockets, take a picture and you can add it to the Padlet. But I'm gonna stop sharing and I'm gonna turn it over to Lucia and she will tell us all about space. So Lucia, take it away.
Great, thank you so much. All right, so I know that you've been doing an entire planetary themed night and we'll keep with that theme. But specifically, I'm going to start to focus on Mars. So a little bit about me. My name is Lucia Bellino. I graduated from Rutgers University in May of 2021, where I got my bachelor's degree in geology. And I just started my PhD in geosciences this fall at the University of Texas at Austin. And I'm really interested in using geochemistry and mineralogy and planetary science to investigate the climate of early Mars. And we'll talk a lot about the research that I do and about that climate of young Mars really soon. But before we get to Mars, we can start at the very beginning at the Big Bang. So you might have heard about the Big Bang before, and what it really is about 14 billion years ago, the Big Bang was an explosion where we had nothing and then there was everything that we know. And so that was the formation of the universe, and it's still expanding today. And so you might be like, how can we possibly know what happened 14 billion years ago? And there are three main pieces of evidence. I think that this one is the hardest to understand. It's called the Doppler Effect, and it was discovered by a guy named Edwin Hubble. So if you've heard about the Hubble telescope before, that's the person that it's named after. And so he discovered something called the redshift, using something called the Doppler Effect. And the Doppler Effect is that as you have something moving, the frequency is changing. So you might have heard like an ambulance or a train or a police car go by you, and you hear the noise that it's making from the siren change as it goes closer and further away from you. And the reason that's happening is because the frequency of those waves that you're hearing is changing as the car moves. And so the same thing kind of happens as galaxies move in our universe. And so they move as they get further away, they have longer wavelengths. And so there's a red shift, which means it shifts to longer wavelengths, to red wavelengths that are longer than the blue wavelengths. And so the only thing that's important to understand about this graph is that it means as you get further and further away, the velocity of galaxies that are further away from us are getting faster, which means that our universe is actually expanding. And so that's the first line, but I think that's the hardest to understand. Another piece of evidence for the Big Bang Theory is that there's this cosmic microwave background energy. And so you would think that if you had the Big Bang, you'd have this like huge explosion of energy, and there should be like some remnant energy still today. And so if there had not been any remnant energy, if you went into space and you took the temperature, it should be 0 degrees Kelvin. But the actual average temperature of the universe, and not just like of the Earth, but of the entire universe, which is everything that exists, is 2.7 degrees Kelvin. And so that's still super duper cold, but it exists, and it's not 0 degrees, it's 2.7 Kelvin. And so some of this energy comes out, if you've ever seen TV static before, about 1% of the static on a TV signal is actually cosmic microwave background from the Big Bang. And so if you're watching your TV and you get a little bit of static on it, you're actually getting to experience like a little piece of evidence of the Big Bang. And the last major piece of the Big Bang, last major piece of evidence for the Big Bang theory is that because this would have happened so fast, you had this explosion of energy, you'd only be able to form the lightest elements. And so if you're familiar at all with the periodic table, you might know that hydrogen and helium are the lightest elements there. And so those are the main two elements that that would be produced during the Big Bang. And so when scientists look at the concentrations of elements that were formed in the universe and that are present in the universe, hydrogen and helium are the most abundant elements, the ones that are most common. And that lines up with what we would have expected to see for the Big Bang. So now that we know how our universe existed, and that was 14 billion years ago, now we can kind of get into our solar system. And so after the Big Bang theory, there was just like this gigantic cloud of interstellar dust. So just a bunch of pieces of these like elements that I just talked about how the Big Bang made, just kind of floating around like little pieces of like space dust. But around 4.6 billion years ago, so still a really long time ago, we ended up having something happen in around us that would have caused like a supernova explosion that would have caused a little cloud to form. So within the bigger cloud, a smaller cloud to form. And all the mass in the cloud would have started to accumulate in the center. So you'd have had more and more mass going to the middle of this cloud. And if you've ever thought about like an ice skater, when they are spinning and spinning and they bend down and they kind of get smaller and they concentrate all of their mass in the center of something, they are able to spin faster and faster and faster. And that's kind of what starts to happen with this cloud, is that you have all of this stuff going to the center and globbing around in the middle. And this disk starts to flatten out and it starts to spin faster and faster and faster. And eventually what happens is that it gets so heavy in the center here that the middle actually collapses in on itself and creates the sun. And so that sun took they took 99.8% of all of the stuff that existed in this cloud went into the sun. And so what was left of this, there's like 0.2% that was left over afterwards, ended up actually making all the rest of the planets in our solar system. And so you end up having the planets form from the other pieces of dust surrounding the sun, where they just kind of have little pieces of dust that start to glob together, and then they get bigger and bigger. And eventually you have the point where you have like, you have bodies that are like kilometers in size that are crashing into each other, making larger and larger bodies. And so this explains why we have our solar system, where if you know that you have rocky bodies closer to the sun, planets like Earth that are rocky, and then you have planets that are the gas giants that are really far away from the sun, they form because closer to the sun, it would be really hard to have water exist because it would be so hot and other like gases. But further out, you'd be able to have more of those kinds of elements. So that's why we have like the rocky bodies, the rocky planets near the sun, and further away, we have the gas giants. And so here's our solar system. You might know what our solar system looks like, but just as a reminder, you have the sun, and then you have Mercury, Venus, Earth, where we are, Mars, and then Jupiter, Saturn, Uranus, and Neptune. And so when I was talking about the four rocky bodies, those are the Mercury, Venus, Earth, and Mars. And then the big gas giants are Jupiter, Saturn, Uranus, and Neptune. And so now we're going to really start concentrating in on Mars for the rest of the presentation. I thought that it might be helpful if you don't have a lot of context for Mars to go over some things about Mars versus Earth. So Mars is actually a lot smaller than Earth. It's only about half of the size of Earth. And you know that we have one moon surrounding the Earth, right? But on Mars, there are actually two moons, and their names are Phobos and Deimos. And so just a little piece of like trivia is that Mars is the Roman god equivalent of the Greek god Ares. And so Ares' two sons in Greek mythology are named Phobos and Deimos, and they're the gods of fear and panic. So those are where the names for the two moons of Mars come from. And the Mars is nicknamed the red planet because it has like this reddish color to it, if you see this picture here of Mars. And Mars is a super cool planet that has a lot of exciting features that are really different than what we see on Earth. So for example, you might have heard of Mount Everest before. It's like the tallest mountain on Earth. And that's here, it's 5.5 miles high. And even though we often think of Mount Everest being the tallest mountain on Earth, Mauna Kea is actually partially underwater, which is why we don't think of it as being the tallest mountain on Earth. But that actually comes in at 6.3 miles, which is already so tall. But Mars has the largest volcano in the solar system, which is called Olympus Mons, and it's actually 14 miles high. So it's more than double as high as Mount Everest. It's gigantic. You can see to scale here how much larger it is than Mount Everest and Mauna Kea. And if you had a picture from space, here's Olympus Mons. You can see this volcano, how big it is coming off of Mars's surface. And here's a picture with Arizona, the state of Arizona, like to scale on top of Olympus Mons. And you can see that this volcano is basically as large as the entire state of Arizona. Mars has lots of other features that are kind of unlike anything that we've seen on Earth before. Here's another example called chaotic terrain. And I just think it's a really interesting and exciting, it's so interesting and exciting to see terrain and features that look so different than what we see on Earth. And the last feature I want to show you is this gigantic canyon called Phallus Marineris. So here it is on Mars' surface. It's almost like a gigantic Grand Canyon, but the Grand Canyon's already gigantic on Earth, but on Mars, this is the United States to scale, and the Grand Canyon would span the entire United States, or not the Grand Canyon, Phallus Marineris would span the entire United States. That's how big it is. What would be able to be the same length as like the entire United States, which is crazy. But something else that makes Mars really, really exciting is that a long time ago, 4 billion years ago, Mars would have had water, liquid water on its surface. And so a lot of times we only think of Earth having liquid water on its surface. And Mars doesn't have liquid water on its surface today, but there's a lot of evidence to support the theory that liquid water existed on Mars about 4 billion years ago. So, for example, here's a picture of one of the rocks on Mars that has, it's called a conglomerate, but it would be formed from processes that had water carrying bigger rocks. You can see like these like pebbles that get put inside this larger rock. And then we also have a lot of features that we can see on Mars that look really similar to what we see on Earth. So in D here's what like a delta looks like. So it's obviously dried up on Mars now because it would have been water there 4 billion years ago. But you can see how, I'll show you in a second too, how it looks really similar to the features that we see on Earth of things like deltas, which are where you have a lot of like rivers and channels branching out. And then you also can see just like individual valleys and channels and the stream beds for those as well. And again, they're all dried out on Mars now, but you can see that they look really similar to what you might imagine if they were dried out on Earth, what they would look like. And you even have crater lakes where like if you would have had a crater, it could have had water. And then you have like rivers and channels that come out of that lake. And we also, we'll talk about this in a second a bit more too, but you also would have, we've also been able to detect minerals that have water in their structure using a special kind of camera that can take pictures of Mars surface, which I'll talk about soon as well. And here's now saying that you could see like a delta on Earth versus the delta on Mars. Here's what delta on Earth looks like. You can see that it's like, blue is where all the water is, and it's very green because there's lots of vegetation. But on Mars, you can see that the structure still looks really similar, where the shapes that you see and the channels look really similar to what we see on Earth. And if you've heard of the Perseverance rover that's on Mars, it actually traveled to a delta location on Mars, where we think that 4 billion years ago, there would have been liquid water. So we have all this evidence that there was liquid water on Mars's surface a long time ago, which is really exciting. But the really big question becomes, how could liquid water have existed on Mars' surface? Because 4 billion years ago, the sun wouldn't have been as bright as it is today. It wouldn't have been as luminous. And Mars is further away from the sun than Earth is. And so it would have been really hard for Mars to get enough radiation, enough sunlight just from the sun to be able to be warm enough to support liquid water. And so scientists came up with two different theories for how you could have liquid water existing on Mars' surface. The first theory was that you'd have greenhouse gases in Mars' atmosphere, like how we have greenhouse gases in Earth's atmosphere. If you think about, you've heard of like global warming and climate change, and those greenhouse gases making the atmosphere, like making the Earth hotter. The same thing could have happened on Mars, when we could have had things like volcanic explosions release gases like hydrogen gas or sulfur dioxide, which are kind of rare gases that would have been like able to keep heat on Mars's surface. The other theory, though, is that Mars could have been covered in ice sheets. And instead of having liquid water visible on the surface, like how it is in the other model here, in this model, you'd have ice sheets, and then you would have had some kind of heat coming from the inside of Mars and kind of the bottom layer of the ice sheet melting to produce liquid water underneath of the ice sheet. And so my research was kind of hoping to be able to investigate this further, if it would be possible to have minerals that would have formed if you would have had this ice covering and then lots of heat and liquid water on Mars 4 billion years ago. And so I was specifically looking in this one area called the Eridania region. And basically what it is a bunch of these like interconnected basins, so like craters and stuff like that, all connected together to basically make this one gigantic area where there could have been a lake. And so, for example, if you see here how you have areas that are higher elevation and like the red and the yellow, and areas of lower elevation that are like the blue and the purple, this outline in black shows you where the Eridania Basin would have been, where all this water would have been, where there's lower elevation. So it's lower, so the water can fill in that area. And so you might think, how is it possible that we could know that this area might have had water in it 4 billion years ago, or that it would have been covered by ice on top of it? But there are certain ways we can look at the shapes of the geology in the region that tell us that ice might have been on top of it by comparing it to similar features that we see on Earth, and also the presence of certain elements or minerals that seem similar to what we see on Earth in environments that have like ice-covered lakes and things like that. And here's a picture of what the Eridania region looked like from space. Again, I think it's super cool. It looks really different from what I'm used to seeing on Earth. And you might also think, how is it important if we have this little basin on Mars? It doesn't look that big, right? But actually, it would have held more water on Mars than all of the rest of the lakes on Mars combined. And it would have been 3 times the largest landlocked sea on Earth, the Caspian Sea, would have all been in this Eridania Sea. So here's the Mediterranean Sea, which you might be more familiar with. It's still much smaller than the Mediterranean Sea, but for example, it's almost 10 times the size of all of the water that's contained in all of the Great Lakes on Earth. And so we're really excited about this region because it would have had so much water there. And we think if there could have been ice on top of it, there should have been some kind of heat as well coming from the inside of Mars. And so if we would have had water and heat, we would have expected certain minerals to form. And a scientist named Mikulski was able to find a lot of different minerals that have water in their chemical structures in this area. And there's one in particular called Serpentine, which he found in this region over here. And Serpentine is really cool because not only does it require water and heat to be able to form, it also produces something called hydrogen gas as it's formed, like the process of forming this mineral. And so there are entire ecosystems on Earth that are underwater that are just bacteria that are able to survive off of the products of serpentinization. So this mineral is formed, it releases hydrogen gas, and the bacteria can basically like eat the hydrogen gas and consume it for energy. And so they don't need other food. They're able to just use that hydrogen gas. And so if we would have had serpentinization and serpentine forming on Mars in this region, it means we would have had heat, we would have had water, and we would have had hydrogen gas, which there are bacteria on Earth that can use that for food, which means we would have had all of the ingredients for life on Mars 4 billion years ago. And I'm not saying that life existed on Mars 4 billion years ago. I'm just saying that if we could find serpentine, it would mean that all of the ingredients would be there. But at this point, we were kind of thinking, okay, so even if you could find this mineral, how would it have been possible that enough heat would have been able to be produced from inside Mars that you could have a mineral that requires really high temperatures to form? But if you've heard about radioactive decay before, you might have heard about it in terms of like radioactive elements like uranium. And so there are other elements like potassium and thorium, and it's not the kind of like potassium that's in your bananas, it's a special version of potassium that are unstable, and in order to get more and more stable and to be able to exist be able to exist stably, release energy along the way. And so when they release energy, they produce heat. And so it would have been enough heat that would have allowed temperatures that were high enough to create minerals like serpentine it would have been able to reach temperatures that are pretty high. And so you can see here in these graphs, the areas that are like orange yellow mean there are really high concentrations of these radioactive elements that decay and produce lots of heat. And these 4 triangles represent the 4 main basins in the Eridania region. And so they both, all of the basins are in areas where there is really high concentration of radioactive elements, which basically is important because it means there would have been able to be a lot of heat produced in these regions, so that serpentine could form and that liquid water would be able to, it would be warm enough for liquid water to exist. And so with all this information, I was hoping to be able to detect hydrothermal mineral alteration, which basically means that minerals got changed because of water and heat that were around throughout this Eridania basin, throughout this region, to be able to figure out how this region formed and if it really could have been a hydrothermal system, a system that had water and heat. So I used this data from a special instrument that orbits Mars called CRISM, which stands for the Compact Reconnaissance Imaging Spectrometer for Mars. Here it is here. And it basically is like a special camera that takes pictures of Mars' surface. And it orbits at 300 kilometers above Mars' surface. And so I'm going to show you pictures really soon. And they look like they're pretty tiny, but every single pixel in one of those images, every pixel is 18.4 meters wide. So actually, look at these pictures. We're looking at like miles and miles on Mars' surface. And so you might be like, how is it possible that we could take special pictures of Mars and be able to figure out what minerals were on Mars' surface? And so if you remember me talking a little bit about wavelengths at the beginning for the Doppler effect, we're kind of going to go back to that right now. So when you see things, we're able to see the visible spectrum of light. And so it ranges from purple to red. And so you might know you can see all the colors in the rainbow. And so everything on Earth, or everything like in the universe, absorbs certain colors and it reflects certain colors. And so, for example, a leaf really absorbs red and blue light. And so the main light that's affected is the green light. And so when we look at it, what we actually are seeing is the green light. And so this instrument is basically a special kind of camera where instead of looking in the visible light spectrum, which is what we can see, and what cameras that, like we have the camera on our phone, it would take pictures looking at the visible light spectrum that we can see. It basically takes pictures in other wavelengths. It takes pictures at 430 different wavelengths in the IR spectra. So not in the visible light spectra, but in the infrared ray spectrum. And so in order to do this, I have to download images from the internet, and they're NASA images. So if you ever wanted to download a CRISM image, you'd be able to as well. And I use special software to correct for Mars' atmosphere and to be able to do some other corrections so that I can actually look at it. And then I can start actually looking at the data in the areas that seem interesting to see if there are actually minerals that are hydrated and see if I could actually find serpentine that I had been talking about before. And so what I did was in this Eridania region, which is the same region we had talked about before, I looked at 350 images in the basin, and I was able to analyze all of these to see if I could find hydrated minerals. And I was able to find that about 70 of these 350 images contained hydrated mineralogy, and including about a third of them had some detections of serpentine in them. And so in case you were curious to see what these images kind of look like, here's the terrain that it looks like. I just think it's really interesting because it looks so different than what we see on Earth. And so we've been talking before about how like leaves absorb certain wavelengths and they reflect other wavelengths. This kind of goes back to this, where the minerals also absorb certain wavelengths and reflect other wavelengths. And so what I really wanted to see is which wavelengths they were absorbing. And so serpentine is able to absorb a wavelength at like 1.9 microns, another wavelength at about 2.315, and another wavelength at 2.5-ish microns. And so when I looked at these images, I was hoping to find that find areas that had these same absorption bands. That's what they're called when you see these kinds of like dips in the spectra. And so here, for example, are 2 lab samples of serpentine. So people on Earth were able to take samples of serpentine in a lab and find out what the spectra look like. And here's what mine looks like from Mars. You can see that these ones also have these absorption bands, and my sample has the same absorption bands at these areas that are important to say, yes, this could be serpentine. And this band right here is just the water band. So when you see an absorption band at 1.93 microns, you're able to say that means that the mineral has water in its structure. And so this one, for example, doesn't have that 2.51 microns band, so it's not serpentine, but it still has the 1.93 micron band, so it means it does have some water in its structure. And so this is really exciting because I was able to detect serpentine and other hydrated minerals throughout the Eridania region, which helps us support the theory that the Eridania region would have been a hydrothermal system, that it would have had heat and water that would have allowed conditions that make certain minerals form. And it's really exciting because the process of forming this mineral called serpentine produces hydrogen gas, which there are some bacteria on Earth that are able to use metabolically. So it means that we would have had water, heat, and something that bacteria on Earth, at least, are able to eat. So there would have basically been all of the ingredients for life on Mars 4 billion years ago. Thank you so much to Dr. Adamo and Julie and Ria for organizing this event and letting me participate. And thank you lots to my advisor, Dr. Oja, who helped me with all of this research and then also let me use a lot of his information from the Geology of Moons and Planets class that I took a couple years ago. All right, thank you.
Thanks, Lucia. That was really great. There are a lot of questions on the doc. I can send it to you if you need it.
I have it right here. Okay, so the first question was, are there meteorites from Mars? And the answer is yes, and there actually is even a small one of those at the Geology Museum. The next question was, do I have a favorite planet? And my favorite planet is Mars, just because I've done so much work on Mars. How did I get involved studying Mars? I started studying Mars because I took this Geology of Moons and Planets class at Rutgers. And I thought that Mars was so interesting because before I took this class, I never even realized that there were other planets that ever had liquid water on them other than Earth. That was like purely an Earth thing. So I was so excited to find out that there could be implications for life existing on other planets. And I thought that Mars was just so exciting because it was so similar to Earth and has these kinds of implications for life existing in other planets a long time ago. Do I want to live on Mars or would I go to Mars? I don't know. I really like Earth, so I'm not sure I would leave Mars. But it would be really exciting if other people go to Mars and bring back samples so that I can look at those samples for Mars. How long did it take for the sun to form? It took like 50 billion years. So basically that big cloud of so basically this like big cloud of stuff sat for like 10 billion years before the sun started to form. And then once the process actually began of this, like all of the matter kind of like glumping towards the center, it actually took like 50 billion years. So somebody asked, NASA recently deflected an asteroid through the DART mission. Can the debris from the deflection come back to Earth and contribute to the climate? That's a really interesting question. A lot of times our atmosphere is able to burn up most of the like meteorites and asteroids that come through the atmosphere. And so they could probably get burned up in our atmosphere before they actually made it to the surface if they're small enough. But I'm not sure actually about that one. I'll have to look into that one more. And I'm not sure when those burn up if they contribute to the climate a lot. A supernova is just the death of a star. So it's like when a star explodes, it's called a supernova. Where did the gas and dust come from in the initial dust cloud? Could it be from past solar system? So that's a really good question. So at first, when you had the Big Bang, you'd have this like giant cloud of dust and elements and gas, and that would have just been formed from the Big Bang. But it's true that there could be other solar systems, or mostly like other like supernova or other kinds of like weird stars. Like there's these things called like neutron stars that are really strange, that are able to form other elements, and those ones got incorporated into our planet and other planets in our solar system. Then they recently find water on Mars. I remember reading an article about finding water a couple of years ago. Was this liquid or ice? So there's ice at the poles of Mars. And I think that there was a paper that came out a while ago that they think that there could be water like in the subsurface of Mars, or like ice in the subsurface of Mars. But I think that's really debated. So I think that the only thing that we know right now is that there is still ice on the poles of Mars. Is lava on Mars similar to the lava on Earth? Is there any data on its makeup or physical characteristics? That's a really good question. I think that Mars is a lot smaller than Earth. And so on Earth, there's like really different elements in the mantle versus on the crust because it had a lot more time to like separate out. So when you have a planet form, it's really hot, and then you'll have kind of like layers form based on how dense those elements or those minerals are. And so the Earth has like very different structure than Mars because Mars had to cool off a lot faster just because it's much smaller. So you think about having like a bigger pot of water versus a smaller, cup of water. When they cool off, the smaller cup cools off much faster. And so is the lava on Mars similar to the lava on Earth? I think it's somewhat similar, but I think that they are different. And I think that they've been able to do a lot of, the scientists have been able to collect a lot of information on the data or about like the makeup or the physical characteristics of the lava based on things like the CRISM instrument that I showed you and other data from other instruments that are also able to get chemical data. And we're also able to learn some stuff about like what Mars looks like based on meteorites, but I'm not sure how much that tells us about the lava. Is there a timeline of when water existed on Mars to carve out all of the rivers and lakes features that we see left over today? I think that most of it happened between 4.5 and 4 billion years ago. And we're able to tell a little bit based on, there was one picture in my slide that had like different, when you have it was called the Amazonian, Hesperian, and Noachian. We're able to kind of age and date the terrain. And so some of that helps us figure out when the liquid water existed on Mars. But I think that we're still pretty unsure of when exactly the liquid water stopped existing on Mars, because we're not really sure how it's possible liquid water could have existed on Mars in the first place. But I think around 4.5 to 4 billion years ago is the main time that liquid water existed on Mars. Does Mars have sedimentary rocks? It does. It has lots of sedimentary rocks on Mars. And so like that one like Perseverance rover that's there right now is looking at some of those sedimentary rocks. Is there any mission that will study and bring home rock samples to Earth? That's what they're in the process of doing right now. So I think that the Perseverance rover is the like first step in trying to bring rock samples home from Mars. But I think that's going to take us like 10 years or something crazy. So hopefully we'll have rock samples in the future from Mars, but I think it'll be a long time. For now, because we have meteorites that come from Mars, we're able to study at least those for now. And they have, can Earth become like Mars someday? I think that at this point, Earth is very different from Mars, but it could definitely become dried out and not have water anymore. A lot of it is dependent, I think, upon when the Earth finishes cooling off, because our magnetic field depends on the Earth still having some internal heat, and that magnetic field is really important for a lot of things on Earth. So part of why Mars is so different than Earth is because Mars doesn't have that magnetic field anymore. And so I guess it's possible, but I actually don't know fully what people predict that Earth will look like, billions of years in the future. Does Mars have Mars quakes? Yes, it does. I think that the mission recently died, but there was a mission called InSight that was on Mars that was able to measure the Mars quakes on the surface, or not on the surface, but was able to measure the Mars quakes on Mars. Does Mars have plate tectonics? No, Mars does not have plate tectonics. Earth has plate tectonics, but Mars does not. And often earthquakes on Mars are causes. So often plate tectonics on Earth is what causes earthquakes on Earth, but on Mars, the earthquakes are much smaller. And then how do I conduct my research? Do I do any experiments in the lab? So for the research that I showed you, all of it was just done on the computer. It was just with like data from this instrument. But now in my PhD, I'm hoping to do a lot more experiments where I could do, I could take samples that look kind of similar to like samples that we see on Mars, and then like from Earth, and then do experiments on them. So I don't really do experiments in the lab, but I'm hoping that I'll be able to do experiments in the lab soon. Mars is red because there's lots of iron. If you've ever heard it, seen rust before, Mars is red because it has lots of iron, which is iron causes that like reddish rust color. And so that's why Mars looks red. It has lots of that iron. Is Mars very hot? Mars is actually very cold. So it's actually much colder than the Earth is. And it's a very cold planet. Why are Uranus and Neptune considered to be twin planets? That's because their size and the composition of them, so what they're made of, and the way they rotate are really similar. And so because of all those similarities in them, they're sometimes called twin planets. Philip would also like to know if we have sent any probes to Mars's two moons. And I don't think that, I'm not positive about that, but I don't think that we've sent any kind of instruments to actually look at, actually touch down on Mars's moons. Is there water on any other planet or the moon? So currently, our moon doesn't have any water on it, but scientists believe that the moon could have had water on it a long time ago, and that there are other moons within our solar system that would have had a lot of liquid underneath of the surface. And so, for example, Saturn has a moon called Enceladus that people think would have a lot of liquid water on it, and same with Jupiter's moon called Europa. And then both of those would have almost have more like salty oceans more than fresh water, and they'd be covered with these like ice sheets on top, kind of similar like how we've been talking about the Eridania region, if it would be covered with ice and then have water underneath. Similar, but with really thick ice sheets. These moons would have really thick ice sheets and then oceans underneath them. Did Mars ever have hydrothermal vents? And that's a lot of what my research looked at in that area. We think that it would have been a hydrothermal region that would have had a lot of hydrothermal alteration. And I think that it probably would have had hydrothermal vents like what we see on Earth. And then Philip wants to know, is there enough atmosphere on Mars for it to rain? It's a really good question. So today, definitely not. Today, there's not liquid water on Mars, and there's not enough. It has a really, really, really tiny atmosphere. But a long time ago, that's what scientists really ask themselves: would Mars's atmosphere have been thick enough for there to be rain on the surface? And so some scientists think that yes, there would have been. Other scientists think definitely not, that it would have just been ice covered and that you wouldn't have had rain. You just have liquid water underneath the surface. All right, I think those are all of the questions.
Yeah, thank you so much, Lucia. I think that was all the questions. There were so many of them. You did a great job and we learned so much. So thank you once again. And thank you to all of our viewers who tuned in today. And don't forget to mark your calendars for our next event, so our next event is actually, I believe, Julie, is it the next late night?
We have an Ask a Geologist coming up, but I have not advertised yet. I believe it's late October. I'll put it on the website shortly.
Okay, so look out for the announcement for our virtual Ask a Geologist. Or that will be, as Julie has said, she was going to put the information up for that. Beyond that, our next late night event will be November 2nd. That one is going to be an Egypt theme. So once again, thank you all, and thank you, Lucia. And I hope everyone has a great night.